So here we have a rocket on an 18-meter cliff being shot at 50 meters per second at 35 degrees. So this is like a type 3 projectile question where the rocket is going to go up, reach a maximum height, and then come back down in a parabolic shape. So the first thing we need to do is take the velocity vector and break it up into x and y components. So I'll find my vx, I'm going to find my vy. And if I do that, I get a Vx of about 41 meters per second and a Vy of around 29 meters per second. Now, in this situation, we want to make sure we separate it at the very, very top. Find the up stuff, then find the down stuff. And on the way up, one of the most important things is Vy, which tells me how long it's going to take and how far it's going to go up. So I can use my Vy to find out how long it's going to take to get to the top. And the time it takes to go along this path and the time it would take to go straight up is exactly the same because gravity is what dictates how long it's going to take for it to stop. So to find out how long it's going to take to stop, I can use basic VAT and I can find my time up is going to be my change in Vy divided by G. And if I do that, it's going to take about 2.9 seconds for it to reach the top. Okay, now I can also find out how high it goes. If I want to find out how high it goes, I can use a couple expressions, but one that works really, really nicely is to use the 1/2 AT squared, and I would only want to use the time on the way up. So if I do that, I can find out that it goes about another 42 meters in the air. So this right here would be another 42 meters. So if I take that 42 meters and I combine it with the 18, I can realize that my maximum height is going to be around 60 meters. And then I found everything basically on the way up. So now what I can do is I can find out some stuff about the way down. And one of the things that comes in handy would be the time. Now, of course, the time for it to come all the way back down along the curved path would be the same as if it just dropped straight down. So let's just drop it straight down because that's going to be a lot easier. So if I do that, my time down, again, the 1/2 AT squared expression works really, really well for this. So if I rearrange it, it would be 2 times the maximum height divided by G and then square root it. And if I do that, it takes approximately 3.5 seconds for it to go down. Now that I have my 2 times, that means my total time of flight will be approximately 6.4 seconds. Now, using my time down, I can also then find out how fast it's going on the way down at the very, very bottom. So my change in Vy on the way down would be gravity times the time down. And if I do that, I realize it reaches approximately a speed of 34 meters per second going down during the second part of the situation. I can then take that and combine it with my Vx, which never changes. That was 41 at the beginning, and it's going to stay 41. And my new Vy is 34. I could take those two, make the triangle out of them, and I can use Pythagoras and trig to find out that my final velocity is about 53 meters per second at approximately -40 degrees. I can also find another total value. I can find the total range of it, or the horizontal distance. Now, Vx never changes, so it's nice constant motion. So range is just basically dtv, where you want to use the total time because it's always moving the x direction, and Vx never changes. And if I do that, I will use the 6.4 seconds for my time. My 41 never changes. I put those two together and I get a total range of approximately 260 meters.